Hey everybody, back here with my final test just to kind of fine-tune what this hydrogen generator likes to work on. We're going to do one more to show you the difference between the sodium bicarbonate and the potassium hydroxide. And I'm at a friend's, they work on radios, and I have a piece of equipment or they have a piece of equipment that I don't have. So they've generously allowed me to do some quick testing with it. So what we got is a DC power supply, and it's hooked up here, positive and negative, and we are currently connected to the system that has a sodium bicarbonate in it. Now, with that, we're going to do some voltage adjustments, and then we're going to see what we have available in the way of production. Once we do that, we're going to switch and we're going to change the voltage on the potassium hydroxide to see the difference in the different voltage range, so that maybe we can fine-tune it and know where we're going to be at. Because once I do these two, I'm going to dump the solutions, because we got 2 tablespoons of sodium bicarbonate and 2 tablespoons of potassium hydroxide in this. I think I'm a little rich in that because of the way it wants to pull. So what I'm going to do is see what half that concentration will do as far as production, because I'd like to minimize the amount of current that I'm pulling for longevity of the system, because we can burn one of these out pretty quickly if we throw too much juice and too much at it. But let's start. Let's see how it goes. So I'm going to turn it on. Oops. And then I'm going to adjust.
Over to the right. There's your standby switch. There's a standby switch over to the right.
Oh, here. There we go. So I'm going to adjust it down. Alright, so there's nothing happening because I put it all the way down. So I'm going to start cranking this up a little bit. And now we're at, about 5 volts here on the meter. Is it the bottom number's volts or the top number volts?
Bottom number.
Bottom number. Okay, so we're going to crank it up. There's 5 volts. And it's not really pushing it. So low voltage isn't going to do it. We need to crank these DC volts up. And we're going to take it to 12 volts. So I'm holding it right here. Here, look up here. So right here we're holding it 12 volts. Okay, and we're going down, and it is just started to run. Okay, it's just started. There we go. We're starting to get the pressure going. Okay, we're only pulling a little over 1 amp. So let's adjust the voltage up to about 14 volts, which is what a standard between 14 and 15 is what a standard alternator is going to run at. And now we're pulling a couple of amps, and we're bubbling a whole lot more. This is about the same equivalent as what I was getting off of that 100 watt panel the other day. Now this may be enough to run a small generator or assist in a small generator, but it's not going to be quite enough for running a vehicle. Now, like I said, this is sodium bicarbonate, baking soda. We're going to take it on up here. 16 volts, 3 amps, and much steadier. But still, we're not getting quite the same as what we did with the other. So, I'm going to pause it for just a second, and then we're going to hook up the other potassium hydroxide system and see the difference, so that you understand why we want to go with potassium hydroxide. Okay, we're back, and it didn't take but a second, but I've got the white and black wires hooked up to the leads from our DC. I've adjusted it down so nothing's happening at the moment, and spin around here, make you dizzy as the dickens, and there's nothing going on here. So we're going to crank it up here, and we're going to adjust it up oops, put it on. I'm going to put it at 5 volts, and it's pulling a little over half an amp. Let's see what that's doing. Nothing yet. Nothing yet. It's not. Oh, wait. It is, but it's slow. You can see the bubble moving down. But this is actually very slow. So let's crank her on up. Let's take it straight to 10. If I put it, oops, it's over current at 11 volts. So we got a very strong mixture.
You can shoot the current, you can up the current. And that's a lot of current.
Look at the difference. So we're not even at 12 volts. So we're going to spin you back around, make you dizzy here. Saying 20.
That's too much.
Yeah. So what I need to do, you see, it won't take any more than that. So I need to. No, I can't adjust it more than 10 volts.
That's because it's current. Power supply's going into current.
Can we? Nope. That's as much as this will give it. So we're maxed out on what this machine will give it. So we're only at 10 volts.
That's terribly efficient.
And we're producing a very strong, steady amount of hydrogen here. Let's try something here. Suppose we put you back on standby. It's adjusted down. Let's take it up to 40 volts and see what it will let me do here. Turned it on. Alright, so nope, it maxes out at 10 volts. So same production, but much stronger. Even at 10 volts, much stronger. So if I could get it back up to 12 volts or 14 or 15, it will significantly pull a lot more ampage. So let's stop it. Alright, next observation, folks. This is the sodium bicarbonate, the baking soda. I just drained it, and pretty much as I have seen with everybody else who's talked about using other electrolytes, you see the color it's turned? Just in the testing that we've done, it tends to brown the water. So we're going to pull the sodium hydroxide next. Alright, folks, to take this one apart, because I had a leak, I went ahead and unscrewed it, so I had to disassemble the plumbing pieces. And quick observation here is, if you look down in there before I dump it, you do not have that same yellowing. It's pretty clear, actually. We'll dump it into the bucket here in just a second. But I had to redo the seal on this because there wasn't enough thread tape on it. So let's set this down. Oh, and somebody told me that they did not see the connection of how I went through the cap, the finished cap, when I was constructing it. So there's a quick look at how it went together. Alright, let's dump this big thing, and we're going to change the concentration. There. And then we're going to dump that. So we'll be back in just a second. Settle in. Alright, we're going to redo this. So this is not super scientific, but alright. Roughly about a teaspoon like that. It's probably not a full teaspoon per se, and something about like that, but I used twice that much before. We're going to cut it in half, so I'm putting it in, and we're using some distilled water, and we're going to fill both of them equally this way. And then I'm going to leave the water volume down just a bit, so that if I choose to fill with some more. In other words, it doesn't do what I want, I can add more. So there we go. Just a little bit of water to stir it up. And where'd the funnel go?
Over on the other desk.
Over here. So here's the funnel. Alright, you're not going to see it come up in volume, but there goes that 1 teaspoon. So let's get the jug, and if you'd come down, and we'll keep an eye on this. Alright, there we go. So we're going to watch this as we fill it. And there it is. This gives it an opportunity to kind of thoroughly mix as it dumps in from the top. And as it's coming up here. Alright, at this mark we're covering the plates. And we're going to take it up. Now at this mark we calculated based on what we were pouring out. As you can see, almost a half a gallon. I used a little bit of this for... I have this most of the way. We're going to leave it, so we're not going to be quite at half gallon. Half gallon was right there, but you can see, you know, how much water we're putting in. So that should give us. Now, if I want to add, I've got a little bit of room to add. But if I like what we're going with the test and seeing what the different voltages do, and if we're still producing as much gas on that concentration, then I'll just top this off with a little bit more water. But that's it. Give me just a second and we'll hook it up and see how it works. Alright folks, just a quick one here. I ran out of battery at my buddy's place, so I wasn't able to show you the last test. His DC power supply would not go up very far, so we couldn't truly test it. But I've got both of them connected. Both of the negatives are there, and then both of the positives are there on my battery bank. And I have replaced the electrolyte in both with 1 tablespoon of sodium hydroxide, or excuse me, potassium hydroxide. I cleaned them out, you saw that, and the idea was to try and find out what worked best and what solution worked best. Now the potassium hydroxide, I didn't need it as concentrated, but as you can see, both of them are equally churning away. So that's it. That's the end of the test, folks. Basically, potassium hydroxide is what you want to use. And when you get into a 12-volt system, and this battery bank is in stasis, or it's not being charged, so we're sitting at about 13 volts, but there's no limit to the ampage that it can draw. I don't know what it is because I don't have an amp meter, but simply put, when it has an option or the ability to, there it is. Now I will say this, it is heating up these cables, so it's pulling some serious current, so I'm going to disconnect it. That just cooked that wire just now, so it's pulling some juice in order to do that. So we're disconnected, shut it off. Point is, that's really rolling when it can have the ampage that it wants. It's not going to need that. At that ampage, I'm thinking we're getting, like we did in the last test, close to 4 liters per minute. Doesn't have to be truly scientific, but enough to know that when we are using this, say in a vehicle, we're going to pull a lot of amps. Obviously, the question is how are we supplying that? That's the next things that I'm going to be sorting out, is how do we supply the ampage that these things need to generate that much. Obviously, the systems that we built here are more than sufficient to produce quite a bit of hydrogen, but you know, there's a lot of YouTube videos, and none of them are 100% specific on all the details, so we each got to fumble our way through in building our own system. So I've got a system here that works well, and works abundantly well, but I'm going to have to fine-tune it as to how I work it into different applications. So that's our next step. Simply put, I think 1 teaspoon of our potassium hydroxide in about a half a gallon of distilled water is going to be pretty well done. Now we can fine tune it even more. I'm not going there. I think what we got is more than enough. So folks, until the next tests and the next steps, let's have fun with this. I hope you guys can do something like this, and maybe do some different tests than I've done. Think of things that I haven't thought of, and let's make this thing work so we can tell the petroleum companies to go sit on a very sharp stick. So thanks for watching, and if this is stuff that resonates with your vibration, please rate, share, and subscribe. And Callie, say hi.